This is R.D. Sharma Solutions, Class 11, Chapter 29, Limits exercise is 29.1. Now this is the first question, and this question is from NCERT. This is a NCERT question. Here we have a function. We have to show that this function does not have a limit. So let me tell you, this is limit x tends to 0, x by mod x, absolute value of x. So what we will do, we'll try to find out the left hand limit, right hand limit, and if the left hand and right hand limits are not same, that means the limit does not exist. Limit does not exist. So what we will do, see, please remember that whenever we have this x by mod x, what does it mean? It means that limit x tends to 0 and we have x by mod x. So if you are putting x as 0, what are you going to get? 0 by mod of 0. Mod of 0 will be 0. So you have 0 by 0, and that is ideal case of indeterminacy. This is not defined ever. You have 0 by 0, you have 0 into infinity, infinity minus infinity. We have others also, like 0 to the power 0, infinity to the power 0, 1 to the power infinity. All these boils down to 0 by 0 only, and that is indefinite. All these forms cannot be computed. We don't know it. It cannot be computed. So 0 by 0 is, of course, it's an indeterminate case. So what we do, we'll go for a limit, and then limit, we have to go for left hand limit and right hand limit. See, this is x equals 0. This is a critical point here because limit is x tends to 0. So we have left hand side, right hand side. So we have to come from left to this point, from right to this point, and we just want to get closer to this point. Not exactly this point, but close as possible. So a, we assume a to be 0. So whenever we want to come closer to 0 from left side, that is, we just stop at certain h point, that is a minus h, very close to 0. This h has to be very small number. We want it to be 0, but it's not possible, so it has to be very small. If we start from right hand side and we go up to this 0 point, what do we get? Up to 0 means we stop at h point, just h distance from a, but it cannot be 0 because it is undefined. So we will just stop a point just before 0, that will be some h point, that is 0, a plus h, 0 plus h point. So this is a plus h. So we'll stop at a minus h from the left, a plus h at the right. So this is the a minus h, a plus h we are going to put in the limits. So let me just show you here. This is limit. First we have to write in the limit form. So limit x tends to 0 minus. So 0 minus, that means left hand side we are approaching 0. And when we are approaching 0 from left hand side, x is equal to 0 minus h. 0 minus h. Okay. So 0 minus h you are going to get here. So 0 is, of course, a. A is the critical point. So 0 minus h we are going to put. A is fixed. So when we change the limit from x to a minus h, a is fixed. But h is going to be, we want it to be 0. So the limit change to h. Limit will change to h because x is already being given to a minus h. So x will be equal to 0 minus h. We will put x as 0 minus h. Now the limit will change from x to h. Now h tends to 0. So in place of x, you just have to replace x by 0 minus h. 0 minus h. So we have 0 minus h, mod of 0 minus h. This 0 minus h, what do you get? X is tending towards 0. So a minus h, that is 0 minus h. What is this h? It's h tending. We want this h to be as small as possible. As small as possible. So h tends to 0. H tends to 0. So we have limit h tends to 0 changed, and limit will be changed from to h tends to 0. And we have 0 minus h by 0 minus h in mod. Minus h will remain in the numerator. The denominator, this mod 0 minus h, because minus h will be in the mod, h will come out. So minus h by h. Mod means always positive will come out. It will be minus 1. So the left hand limit has come to -1. Similarly, this -1 as we got from the left hand side, we'll try to find out for the right hand side. As I said, we have to put a plus h, a is 0, so 0 plus h, 0 plus h. So now you have to change to x tends to 0 plus, because we are talking about the right hand side. So 0 minus 0 plus h you have to put 0 plus h. Now when we change from x to 0 plus h, we have to take h as small as possible. We ideally want to be 0, but when it becomes 0 it will be indeterminate. So h has to be very small. So in place of x you put 0 plus h. You will get, now limit x tends to 0 plus will change now. It will be h tends to 0. X tends to this 0 plus superscript is change. So this is 0 plus h by 0 plus h in the mod. So now limit change to h now. Limit change to h now. So we have 0 plus h by mod of 0 plus h, and this in the numerator we have h by h, because mod h plus will come out. So it will be 1, h by h cancels. So now 1 is right hand side limit. So left and right hand limit are -1 and 1, which are not equal. So when these limits are not equal on either side, that means limit does not exist. It doesn't exist. So why did I explain you? Because most of the questions are like this only. Same concept we are going to use everywhere almost. Now question number 2 we have. Now find k such that limit fx x tends to 2 may exist for where fx equals to, there is a proper function. This function is telling you that if x is less than 2, 2x plus 3, x is greater than 2, it is x plus k. So what is this significance? How do we perceive this question or with this function? Let me show you here that we are talking about, just take me to the number line. This is x equals 2. This is a critical point. It is saying that it is a critical point, but it is not going to be 0, infinite, right? Anything. So we are talking about left hand side and we are talking about right hand side. So left hand side means 2x plus 3, and right hand side is, so if x is less than or equal to 2, we have to take y equals 2x plus 3. It is a straight line. When we have right hand side, that is if you go up 2 or add something to 2, it has to be x plus k. It has to be x plus, so right hand side. So you are talking about x plus 2, x plus k, x plus k. So when we take left hand limit and right hand limit, then we have to find out k for it. K is not known. Limit x is existing, so left hand, right hand equate. That is going to be the way we find out k. So now we have a is 2. Left hand limit, a is 2 is the critical point. So a is 2. So there is small h before 2 we are going to stop. We start from left hand side. So we have to put x as a minus h, that is 2 minus h. 2 minus h. And then we have this right hand side. When we approach 2 from right hand side, we'll stop near 2. Means about h distance from 2. So 2 plus h we are going to put. So let us take left hand limit and right hand limit, 2x plus 3, and this you have x plus k. So left hand limit, you see, limit 2 minus, this is x is 2 minus, so we have 2 minuses from left hand side. So fx will be equal to limit x tends to 2 minus, and when we are talking about left hand side, that is below 2 or equal to 2, it's 2x plus 3, 2x plus 3. So this is 2x, we will change to 2 minus, because we have to change the limit to h. So limit h will be tends to 0, h has to be as small as possible. So in place of x I am putting 2 minus h. In place of x I am putting 2 minus h. We have to replace x by a minus h. A is 2 here. So just solve it. H tends to 0, so you can just remove this. 2 into 2 is 4, 4 plus 3 is 7. So we have limit h tends to 0. H you have to remove because you are putting h as 0. When you put h, just forget about h then. Limit have already been applied. So you have 7 here. This is left hand limit. Now coming to the right hand limit. Right hand. Now for this, function has changed. Function has become x plus k now, because we are going up to. So we have this as limit x tends to 2 plus h. So 2 plus, when we'll put 2 plus, that is we are going to on the right hand side. So fx will be equal to, the function is going to change. It will be now x plus k. So x tends to 2 plus, it will be what? It's x plus k, x plus k. Now this x plus k, now you know that we have this 2 plus, we have to replace by 2 plus h. So we have limit, now we have to replace the limit also. It will be h tends to 0. 2 plus, so 2 plus h, we just go up. So in place of x, you put 2 plus h. So 2 plus h plus k. Now h is tending to 0, so when we put h tends to 0, we'll not use the limit. So you have 2 plus k. So this will be 2 plus k. This is right hand limit. Now left hand limit, right hand limit. Left hand limit, right hand limit. So we have left hand limit equal right hand limit. It has to be equal. So k will be equal to 7 minus 2, that is going to be 5. So k will be 5 for LHL to be equal to LHL and the limit to exist. Now question number 3 we have. Show that the limit x tends to 0, 1 by x does not exist. So what we will do, I'll just show you what does it mean actually. So we have left hand limit and right hand limit we are going to find out, and we'll show that they are not equal. They are not equal. So 1 by x, where the problem is, when you put x equals 0, 1 by 0 means what? It is infinity. Whenever you divide anything by 0, it's infinite. It's infinite. So critical point is x, when you put x equals a plus h, x minus h on the right, for right hand one, so you have a as 0 and a as 0, so 0 plus h and 0 minus h. So left hand limit, right hand limit, okay. So just put it here. So limit is 0 minus, so we are showing that it is on the left hand side. We are talking about left hand side. So 1 by x, now put x as 0 minus h. 0 minus, oh, I need to change it. There is a slight error. This is 0 minus h, a minus h, this is a plus h on the right hand side, and so 0 minus h I am putting on the left hand side. And 0 minus h, now you have to change the limit of h also. So if you put h as 0, 1 by minus 0, 1 by 0 is infinite. As I told you, 1 by 0 is infinite. 1 by minus 0 is minus infinite. Minus infinite. Infinite is what? Infinite is any number which is not countable. We don't know that infinite number. It can be anywhere. No. So when we go to right hand side, 0 plus h I am putting. So you have 1 by h. 1 by h is again infinite. 1 by 0 is infinite. So you see the left hand and right hand are not equal, because infinite is a number. It's a proper number, but we cannot define it. If you come with any number, I'll just add 1 and I'll say this is not infinite. Infinite is the end point of this number line, which is not known. We will never reach that highest number. It can be, you can go to highest number to any extent you want, but we know that there is a number. Infinite is just a representation. So that is the solution. Question number 4. Now we have to show that the limit x tends to 0, e to the power minus 1 by x does not exist. So we'll do the same thing here. So I'll just show you what we are going to do briefly. So we'll say limit x tends to 0, e to the power minus 1 by x. Now we know x tends to 0, that means it's a critical point. That is the point where we have to check, and the limit is discussing. We are discussing. So x equals a minus s, x equals a plus h, left hand side, right hand side. 0 minus h we are going to put in the left hand side, and 0 plus h we are going to put in the right hand side. Okay. So we have limit. Now 0 plus, what does it mean? 0 plus, you have to put 0 minus h. No, 0 minus. In terms of 0 minus, we are going to put e to the minus 1 by 0 minus h, because we are taking left hand limit. Minus 1 by 0 minus h, minus 1 by minus h, it is minus 1 by minus h. What does it mean? Minus 1 by minus cancels, it's 1 by h, and 1 by h is infinite, 0. So 1 by 0 is infinite. So it is e to the power infinite. E is a proper value, 2.732 I guess. And if you go to infinite, it is infinite. Now coming to the right hand side. So we have e to the power minus 1 by, in place of x I am putting 0 plus h. 0 plus h. So it is minus 1 by h. E to the power minus 1 by h. So e to the power minus 1 by infinite, 1 by 0, that is e to the power minus infinite. E to the power minus infinite. So when we have e to the power minus anything, we can always write it as 1 by e to the power plus of that thing. So 1 by e to the power infinite. E to the power infinite is infinite. So 1 by infinite is what? So if you want to divide 1 by infinite, any number which is very huge, it is going to be 0. Ultimately, it is going to be 0. Anything which is having multiple, you can't even count zeros. If you divide 1 by or any number by infinite, it is going to be 0 always. You will never reach that infinity, because that number I will always add 1. I will say this is the infinity. So infinity is a proper number, but we don't know it. It goes beyond our comprehension. But 1 by beyond our comprehension division is 0. So you have left hand limit, right hand limit, infinity and 0. They are not equal. So limit does not exist. So let me show you formally. So we have limit here. We started with left hand limit, so 0 minus, and right hand 0 plus. In place of x, we put 0 minus h in the left hand side and 0 plus h on the right hand side for the right hand limit. So we have x tends to x when you put 0 minus h. Here you put x as 0 plus h. So we have 0 minus h. Now h tends to 0. Both the sides, h tends to 0, you have to change. So it will be infinite, and e to the power on the right hand side, you have e to the power 1 by minus 1 by 0, that is going to be minus infinite, as I just told you. E to the power 1 by e to the power infinite is going to be, or infinite is going to be 0. Just remember, anything to the infinite is infinite. Anything below, whenever we have division, when you have infinity in the below, it will be 0. So this left LHL, RHL are not equal. Limit does not exist. Now question number 5 here. Now I hope the concept is clear to you. So we have here question number 5. Show 5. Show that. Let me write the question here so that you understand. And here we are going to use the greatest integer function, or this square this one. So we have this question. Let me write the question first, then I'll explain. So we have x by this square bracket. Okay. So we have limit, left hand limit, and you have right hand limit. So we have this 2 minus 2 plus. This is given in the question. Here we can see easily that the critical point is what? 2. A is 2. So x will be written as 2 minus h left hand side. X will be 2 plus h on the right hand side. 2 minus h, 2 plus h. So when we put it here, if you see this 2 minus h, I am putting just 2 minus h, 2 minus h and 2 minus h. So this 2 minus h, this function I am going to tell you, this is the function that simply means you have to take the lower integer, whatever value comes. So 2 minus 0.5 is 1.5. So you have to take 1. I'll just show you with some more example. Whatever number you take, this 2 minus h will be between 1 and 2. If you subtract any number, that is 0.1, 0.2, say 0.2, if you subtract, what will be? 1.8. You have to take 1. If you remove 0.5, 1.5 will come. Then again you have to take 1. Means the 1 will come out. 1.2, 1. So in between 1 and 2 integer, you have to take always 1, the lower one you have to take. So 2 minus h, if you subtract something from 2, it is going to be somewhere near 1. You have always to take 1. So we have 1 always. Integer value you have to take, and that will be the lower, you can say the floor you have to take, floor. So 2 minus h, you are putting 2h as 0, so 2 minus 0 by, and 2 minus h, of course, in the function it will come out as 1 always, because you have to take between 1 and 2, and 1 will always come. So you have 2 by 1, that is going to be 2. On the other one, you have this one, right hand. Now right hand, this is What do you have to do for right hand one? You have 2 plus h by, this is 2 plus h again. Now I told you that whatever you do, you have to be between the integers and you have to take the lower one. So if you add anything to 2, say 2.2, 2.5, 2.8, whatever is the value between 2 and 3, always 2 will come out. This square bracket function always tells you that, right? So you have 2 always in the denominator, 2 plus h, that is h is 0 always because h tends to 0. 2 plus 0 by 2, so you have 2 by 2, that is going to be 1. It's going to be 1. So you have 1. So right hand is 1, left hand is 2. So they are not equal. That means the limit does not exist. 39.1. This is question number 6. The question is saying let fx be a function defined by fx, and this is having this definition is fx is 3x by mod x plus 2x if x is not equal to 0, and it is 0 if x is equal to 0. Now we have to show that limit x tends to 0, fx does not exist. So this f0, if I put f as 0, what do we get? 3 into 0 by mod 0 plus 2 into 0, that is 0 by 0. That is, it is an indeterminate case. Indeterminate case. So for 0 it is x equals 0, but what we have to do is we will find out show that limit x tends to 0, fx does not exist. So we'll find out the left hand limit, right hand limit, and then we will try to prove or say that they are not equal. Okay, then only we can show this. So let me show you here left hand limit. This is x equals a minus h, you have to write it. Critical point is 0. So x will be 0 minus h. And this 3 into 0 minus h is minus h only. So 3 into minus h by mod minus h and 2 into minus h. So we have x, when you put x equals 0 minus h, that is a minus h, a is 0. Now you don't have to do anything with x, you have to do with h. Now h tends to 0 because already you have put x equals 0 minus h. So you have limit x tends to 0 and 3 into minus h by mod minus h. Mod minus h, in the mod only positive will come out. So you have h, of course you have minus 2h. So minus 3h by minus h, that is going to be 3. When you remove this h, you don't have to worry about limit h tends to 0, you don't write it. Now coming to right hand limit. Now same thing you have to do. You have done 0 minus h here, you have to do 0 plus h. So 0 plus h, that is h. So 3h by mod h plus 2h. So this is 3h by h plus 2h. That is going to be 3h by 3h, and it's going to be 1. So 3h by 3h, it will be 1 and limit will remove. So you have the left and right limit, they are not equal. So left hand limit is 3, right hand limit is 1, they are not equal. That means this does not exist, limit will not exist. Now this is question number 7. It is saying that evaluate limit x tends to 2 fx if it exists, where fx equals, there are three part of this function. So first is fx equals x minus this is not mod, this is a greatest integer function. So we have a square bracket. So this is a greatest integer function. So now this function x is less than 2 and it has to be 4 if x equals 2 and 3x minus 5 equals x greater than 2. So here we have to evaluate the limit. So x tends to 2. So we have to evaluate. Now if you see here, let me just make it here. We have a 2. 2 is a critical point here. Now this 2 is a critical point or a point. On the right hand side and left hand side, we are provided proper equations. So just when you have x less than 2, the function becomes x minus greatest integer function, this one, x. And then on the right hand side, that is x greater than 2, it's going to be 3x minus 5. 3x minus 5. So for the left hand limit, we will put a minus h. For right hand limit, we will put a plus h. A is what? Critical point is 2 here. So if it equals left LHL, RHL are equal, limit exists. So critical point is 2, so left hand side A minus H, A is 2, 2 minus H. Right hand side we are going to put 2 plus H. So see here we have fx, x tends to 2 minus, so we are talking about this less than 2, x minus this function, greatest integer function. So here we are x minus greatest integer function, and this in place of x we are going to put 2 minus h. 2 minus h. So when we put 2 minus h, I told you 2 minus h you have to write. So when we put 2 minus h, x is 2 minus h, and this greatest integer function of 2 minus h. I told you in the previous question, whenever you subtract anything from 2, the value will go to 1. That is, in between 1 and 2, whatever with the value, it will always give you outside 1. So 1 and 2, anything you are subtracting from 2, where you are going to get? You are going to get 1. It is 1.5, 1.8, it doesn't matter. It will always take an integer value 1. That is the output of the greatest integer function. So 2 minus 1, here 2 minus 1 is what? 1. 2 minus h minus, this h is of course 0. 2 minus h gives you 1, so 2 minus 1. Now coming to right hand limit. Right hand limit, same thing, but 2 plus you have to write. And this 3x minus h, in place of x you are going to put 2 plus h. In place of x, 2 plus h you have to put. So 3 into 2 plus h minus 5. 3 into 2 plus h minus 5. H is of course 0. 3 into 2, 6. 6 minus 5 is 1. So you have limit x tends to 2 plus. 2 plus means 2 plus h. We are talking about right. 2 plus h. 6 minus 5 is 1. Now as I said, LHL, RHL both are 1. That means they are equal to 1. This is question number 8. Show that limit x tends to 0, sine 1 by x does not exist. It does not exist. So question number 8 it is. So if you see here, sine 1 x tends to 0, sine 1 by x. Now if I put x as 0, whatever come inside sine, it will always, 1 by 0 is infinite, but whatever is sine infinite, so when any value of sine will always be between minus 1 and 1. So let me prove it. We know that it is not, the limit will not exist because it's clear from here. But let us prove it. So we have the left hand side and right hand side limit we will find out. First, left hand limit will only give you the answer. So you have to put 0 minus h because a minus h, a plus h, LHL a minus h, right hand side this plus a plus h. So limit x tends to 0 minus fx. Fx is sine 1 by x. Sine 1 by x. In place of x I am putting 0 minus h. So limit h tends to 0 now, sine minus 1 by h. Now this 0 minus h, that is sine minus 1 by h. Sine minus theta is minus sine theta. So minus you can take out. So it will be sine 1 by h. Now sine 1 by h, again h is 0. So this is sine infinite. That is, whatever you put, x tends to 0 minus, fx is going to be negative of all the values which are oscillating between minus 1 and 1. And when you try to find out the right hand limit, it is going to be plus bracket you can write an oscillating number that oscillates between minus and 1. So it will be negative and the right hand limit will be positive. So they are not equal. When the left hand limit, right hand limit are not equal, limit does not exist. So you have to find out that 0 plus h also, okay? 0 plus h you put, that is 1 by 0 plus h is sine 1 by h, and that is going to be this positive side of what we have seen in negative. Question number 9 now. Find a limit greater than integer function x tends to 5 by 2. Now this question is repeated again in 14th question. So just see it very carefully because this is repeated. It is coming later. So you have 1, 2, 3. Let me make a number line. So we are talking about 5 by 2. That is, we are talking about 2.5. This is 2.5. 5 by 2, 2.5. This is a critical point also. Critical point. So here we have left hand limit. X. We have to put a minus h. A is here 5 by 2. A minus h. So 5 by 2 minus h I am putting. You know 2.5 minus h, whatever you subtract 2.5 minus h, as you know that because of this greatest integer function, you will always get 2. Whatever you have between 2 and 3, you will always get 2. So we have 5 by 2 minus h, you will always get 2. Now coming to the positive side, that is 5 by 2 plus h. 5 by 2 plus 5 by 2 plus h, what do you get? As I'm saying, 2.5, whatever you add, you'll always go to 2 only. You're adding very small value to 2.5, that will be made 2.6, 2.7, whatever. But it is going to be 2 because this is a greatest integer function, always take you to the lower level of integer value. So you have this 2. So left hand limit, right hand limit are equal and limit is 2. That is the value of limit is 2 and LHL, RHL are equal. So limit is existing, it's 2. Now question number 10 now. Find limit. The question is like this. Find limit x tends to 3 plus x by greatest integer function x, and it is being asked, is it equal to limit x tends to 3 minus x by greatest integer function x? So we have already seen this type of question number 5th. If you see question number 5th, only the change is 2 minus and 2, this is 3 minus, or 2 plus and 3 plus, only this has changed. So left hand limit, right hand limit, we have to put 3 minus h on the left, 3 plus h on the right. So left hand limit, right hand limit, let us say the right hand limit first. So we'll put 3 plus h here, 3 plus h. So x equals 3 plus h, so put 3 plus h, x equals 3 plus h, now 3 plus h by 3 plus h. So 3 plus h will be 3, h is 0. But whatever you add to 3, the greatest integer function will always be 3. Because it will always take the lower integer value. Floor, you can say floor. Either whenever you are before 4, it will always be 3. So 3 plus h is 3 plus 0 plus by 3. So this is what? You will get 1. 3 by 3 is 1. Now take 3 minus h. I am taking left hand limit. So I am putting x as 3 minus h. 3 minus h by greatest integer function 3 minus h. 3 by this 3 minus h. Now when you subtract anything with 3, it will always go to 2. That is the lower end of the integer. So 3 minus h. We have 3 by 2. That is 3 minus h. This function, you have to really be knowing this function. Otherwise, there are so many questions here. It will be difficult to understand. So let me tell you again. Greatest integer function means whatever will be the decimal value in between, fraction value in between, it will always take the integer value lower side. Whichever this value is in between, those integers, lower integer will be taken. So you have 1 and 3 by 2, so LHL, RHL are not equal. Now question number 11. So we have limit fx equals x plus 1 and x minus 1. And x greater than or equal to 0, x plus 1, x less than 0, it is x minus 1. It's clear that 0 is a critical point. 0 is a critical point. This is A. We are going to use A here. We have to prove that the limit fx does not exist. Limit fx, x tends to 0, does not exist. So you have x minus 1, x plus 1. So you have left hand limit and you have 0, 0 minus h. We are putting here, and 0 minus h we will put x minus 1. And on the right hand side, this 0 plus h you will put in the x plus 1. Just remember this. 0 minus h in x minus 1 function, and right hand limit, because we have fx will be when we are talking about 0 plus, that is you are talking about right hand side, that is you have to take x plus 1 function. So x plus 1 function. Okay. So x in place of x put 0 plus h. So 0 plus h plus 1. That is going to be limit 1, h is 0. So 1 will be the answer. On the left hand side, we have to put x minus 1. And in place of x, you are going to put 0 minus h. So fx extends to 0 minus fx. So you have x minus h. X is 0 minus h. 0 minus h minus 1. Of course, you will get h is 0. So you get minus 1. Okay, minus 1. So we have left hand limit not equal to right hand limit. That means this function does not exist. Limit does not exist. Question number 12. Question number 12. Find the limit x tends to 1 plus, that is right hand side a plus h, 1 by x minus 1. We know 1 plus 1 is a. And 1 plus means you are adding h to 1. The right hand limit we are talking about. 1 is the critical point. You have a as 1. So a plus h. A plus h. So 1 plus h you have to put. 1 plus h. So x you have to put 1 plus h. Just put it here, 1 plus h. 1 by 1 plus h minus 1. You have 1 by h, that is infinity. So infinity. And as I said, infinity is a value, is a number. But that number we don't know. It is a number, but it's a very huge number. We don't know, because even if you come with any number, I'll just add 1 and I'll say here is the highest number now. So infinite is a symbol to show the highest number. So it is not undefined. It is not undefined. It is a number. But the problem is we don't know that number. Infinite is the symbol to show that. Infinite. Now we have question number 13. Now prove that limit x tends to a plus this greatest integer function x equals same. On the right hand side we have a. So limit x tends to a square bracket x equals square bracket a for all a belongs to R. I just missed this limit x tends to a plus the square bracket x. I just missed it, so you can just add it. And we have to prove that limit x tends to 1 minus this square bracket equals 0. Now you know a plus means a plus h you have to do. What is the function? Function is greatest integer function. A plus h, just you put a plus h. Now a plus h simply means a is an integer and a plus h plus 1 is the other integer. Whatever you add a, h to a, h is very small. It will always be a. Like in between 2 and 3, you add anything to 2, it will always be 2. Now coming to 1 minus, you have greatest integer function x, you are subtracting something from a. When you are subtracting something from a, that is 1 minus h you are saying. So 1 minus h, I'll just show you here. 2, 1. You are subtracting something from 1, that is you are talking about 0. You will go to 0. Okay. This function always take the the floor of integer. Question number 14. And all these 3 questions we have already done. We have done. As I was saying in the question number 9, I guess. So we have the 3. So let me tell you again that whenever we have this greatest integer function, those who have understood it's good. But greatest integer function, that simply means if you are between 1 and 2, and you have any value, say 11 and 12. Now change the value, change the number now. We have done 1 and 2 number of times. 11, 12. If it is 11.2, it is 11.4, 11.8, whatever you put, you will always get 11. Whatever be the case. Even 11.9, 11.1, you will always get only 11. Right? So now let us go to the question here. We have limit x tends to 2. This is square bracket, that is greatest integer function x. So we have left hand limit LHL. This x tends to 2 minus h. Right hand side you are going to use 2 plus h. Now 2 minus h, 2 is the critical point, x tends to 2. So 2 minus h. So first we will put left hand limit. I'll put x as 2 minus h. X as 2 minus h. So when you put x as 2 minus h, what do we get? Now when we put 2 minus h, that is we are subtracting something from 2. We always get 1 less, that is 1. Between 1 and 2, you are subtracting 2, something from 2. So you are going to get what? In right hand side, you are going to do 2 plus h. You are adding something to 2. Whatever you small add to 2, you will always get 2. Always get 2. So LHL, RHL are not equal. One time you are getting 1, one time you are getting 2. So they are not equal. Limit does not exist. Now this is the second one. This we have already done. This question, as I said, we have already done. This is the ninth question. If you go back, we have already done. So now I'm skipping it. I'm going to the third one. And this also we have done, but just for the sake of completion, I'm doing it. So here we have limit, same function, x tends to 1. So just let me complete just for completion. So x tends to 1, we have a equals 1. Now left hand limit, we will put a minus h, that is 1 minus h. On the right, we'll have 1 plus h. So we will put 1 minus h here, x has 1 minus h. So x has 1 minus h, you know whatever you subtract from 1, you will go to 0. And whenever this is 1 and 0, whatever you subtract, it will go to 0. Greatest integer function always give you 0. So now right hand limit 1 plus h, you are adding anything to 1, it will be 1 only. Whatever you add to 1, it will be 1 only. So 1 and 0, RHL, LHL are not equal, does not exist. Limit does not exist. Now this is question number 15. Now this question is having not many parts. So you have 11 parts in the 15th part only. 15th question, 11 parts. So let me take it in the next discussion. Okay. Thank you so much. Take care of yourself.